This video, we are looking at recurring decimals. Have you ever been told of by your parents before? Recurring decimals are like that. They go on and on and on and on forever. Just kidding. They just want to make you a better person from their experience. And the truth is sometimes hard to swallow. Anyway, the learning objective today in this lesson is just one objective really, which is to convert recurring decimals, or known as repeating decimals, to fractions. To convert recurring decimals to fractions, you can try to follow the steps below. Let n to be a number with the recurring decimals, and then go write the number long enough that the digits repeat itself at least twice. We're going to multiply by 1, 10, 100, 1,000, or sometimes 10,000 in some extreme cases, to get two different numbers but have the same repeating decimals. Once we've got two different numbers with the same repeating decimals, we can subtract the big one minus the smaller one, and we'll form an equation, and we can make it into a fraction. In the first example in here, we're going to do the first three steps just to get used to what I mean by writing two different numbers with the same repeating decimal. So a bit of warm up before we go to the real question. So we're going to multiply each of the following number by 10, 100, or 1,000 until two different numbers have the same repeating decimal. So A, okay, so I'm going to let n to be the recurring decimal. So n equals 0.8 recurring. Recurring means 0.88888. You can go on and on and on and on forever, but we're going to stop there. And then if we times by 10 means move decimal backwards once, so forward ones rather, forward one, so it'll be 8.88888. Now what you can see in here is the decimals, the numbers after decimal point are now exactly the same. So we've got two numbers in here which is exactly the same with repeating different numbers but the same repeating decimals. Part B, okay, so n equals 0.34, both recurring, so it means 0.343434, b boo. Next, if we do 10n, okay, if we times it by 10, move decimal forward once, we get 3.434343, b boo. Right, they're not quite the same, okay, because you can see 3434, 4343, so not the same. So we go on after 10n, we do 100n. So multiply this by 10 again, so it becomes 34.343434, b boo. Right, then in here you can see these two numbers have the same repeating decimal. Okay, so we're done. Okay, so in other words, we're going to choose the n equals that one and 100n. Okay, right, C, 1.423, we're going to let n to be 1.423 for n3 recurring. If you've got recurring symbol on 4 and 3, it means everything in between are recurring. So it'll be 1.423, 423, 423, etc. So let's do 10n. Okay, so I'll try to align decimal points. So decimal point is here. Times it by 10 means 14.234. Not aligning. Okay, 100n. Times this by 10, so decimal point here. Times it by 10 means move decimal point forward ones, so 342. Not quite the same again, so this time we times by 1,000, so decimal point here, bring the 3 there, so 1,423.423. Oh, what we realize is this is the same as that one. So to be honest, the middle ones are not important. Okay, so what we need is these two numbers, the first one and the last one, if we want to work out repeating decimal later. Right, D. This time, 3, we're going to let n to be 3.657 recurring on 5 and 7. Now, that means a 6 is not recurring. So if I have to write out in full, it'll be 3.6 and then 57, 57, 57, etc. So it's just a 57 that is repeating. This time, let's times it by n, times it by 10. And 10, they rhyme. Anyway, so decimal point there, 36, 57, 57, 57. Are they matching? Not quite, because this 657, 57, but this just 5757, so it's not quite matching. So we can do 100n. So decimal point there, times it by 10, so 365. 75, 75, 75. None of them matching. 1000n. So decimal point there. 3657, 57, 57, 57. Finally, that's matching. But this time it's not matching with the first one. We're matching with the 10n. So we are going to use, if we do have to use it for calculation later, we're going to use the 10n and the 1000n. This time, practice question 1. Have a go, your turn. So try to write these numbers, each of these numbers, with until two different numbers have the same repeating decimal. Essentially what we did in the first example here, I want you to find the two numbers that have the same decimal, repeating decimal. Okay, you can pause the video, have a go at the question. When you're ready for the answer, you can press play. Okay, here are the answers. So I've tried to do them all to show you how to work it out one by one. But if you're quick enough, hopefully you do recognize some sort of shocker for yourself, especially if the recurring decimal start from the first digit after decimal point. Let's say 0.45 recurring in here, because at 2 digits you will know is 100. Like similar for D, because it's the first decimal is a recurring. 465 means you need 1000n. That's a kind of shortcut, but if you don't get a shortcut, it's fine. Just do it one by one until you find two of them the same. Example number 2. This time we're going to write each of the following recurring decimal as the simplest fraction. So we're going to write them in fractions. So we're going to perform the same step like the previous example. Now I deliberately choose the same number for the previous example to make it a bit quicker and a bit more easier to explain. So I used the working out in the previous example A, 0.8 recurring. So part A, I'm going to let n to be 0.8 recurring again. Okay, 0.88888. But I know for a previous working out, I can use 10n, so 10n equals 8.8888. So what I can do next is I can use the 10n, subtract the n. So if you do, see if I rewrite the whole thing out, it'll be 10n equals 8.888 and n equals 0.888. I can do a little column method, subtract them, because the 0.888 will cancel out. Now that's why we do the previous exercise. We need to make sure the recurring decimal at the back are lined up, so when they take away from each other, that goes to 0. 8 take away 0 is 8. Therefore, to be honest, the decimal doesn't matter anymore, because 8.0 is the same as 8. 10n minus n is 9n. So n equals, divide by 9, n equals 8 over 9. So you can use a calculator, double check your answer. 8 over 9, it should give you 0.8 recurring. Part B, 0.34. So we let n equals 0.34, 34, etc. So let me previous working out. 100n, so I'm going to write 100n equals 34.3434. So again, if I be a bit cheeky and just move this down here, so what you should do, what you get is n equals 0.3434. Make sure when you take away the decimal point, just line up. 3434 behind decimal point and 3434 behind decimal point cancel out. So 34 minus 0 is 34. Equal. 100n minus n is 99n. So n equals 34 divided by 99. Now you know this can't be simplified because 99, there are not many factors going to 99. 1, 3, 9, 11, 33, etc. But you know, 34 is not divisible by 9 or 3, so we don't have to simplify anything. Question C, 1.423, so n equals 1.423. So let me have a look at the previous one. 423, I have to use 1000n, so do that. 1000n equals 1423.423, 423, etc. So again, do the same trick. I'm going to bring this down here. So n equal. Note how I line up the equal sign, and also I'm going to line up decimal point as well. So look at here and look at here. Make sure they line up, so it's just easier to take away. So 423 minus 423, that's gone. 1423 subtract 1 is 1422 equal 1000n take away n is 999n. So n equals 1422 over 999. Now, question is 100 1422 divisible by 3? Now, that's a question you need to ask yourself, because if it is divisible by 3, that means it could be simplified. And I'm not sure if you know this little trick about divisibility about 3. You can easily work out if a number is divisible by 3 or not by adding all the digits. If the digit sum is divisible by 3, then the whole number is divisible by 3. I'll give you an example in here. 27 is divisible by 3. Okay, we know that. 2 plus 7, if we add the digits together, 2 plus 7 is 9, because 9 is divisible by 3, therefore 27 is divisible by 3. Another example, what about 111? Is this divisible by 3? Well, if I do 1 plus 1 plus 1, that's 3. 3 is divisible by 3, so 111 is divisible by 3. Okay, you can use this trick for all numbers that works divisible by 3. Now, it doesn't work for any other digits, okay? 4 or 5 doesn't work that way. Only works for 3. So we can use this trick to check 1422. So 1 plus 4 plus 2 plus 2 is 9. 9 is divisible by 3. Therefore, I know this is divisible by 3. So my next step is to work out, simplify the fraction. Okay, so I need to do 1422 divided by 3. So 3, 4. Now this is a skill you need to do in exam as well. So 474 over 999 divided by 3 is 333. You want to check, again, 434 is divisible by 3 or not again. So 474, so 4 plus 7 plus 4, 11 plus 4 is 15. 15 is divisible by 3. Therefore, you can simplify again. So you have to divide by 3 again. So you get 1, remainder 117. So that'll be 5, remainder 2, 8 over 11, 111. So for question D, assume I haven't got the answer from a previous example. I'll just do one question from the very beginning. Okay, so I'm going to let n, question D, I'm going to let n to be, I can't remember the question already. I've got goldfish memory. I'm sorry. 3.657 recurring. 3.657 recurring. So what I'll do is, first thing, I'm going to write them out a few times just to make it easier for me to read. And then I'll do 10n. I'll probably skip 10n. If you know 10n is not relevant, you can skip 10n. 36.5757. 100n is 365.757. Again, it's not the same. As soon as you've done the first decimal, you realize it's not matching up, you can sort of do a couple of them and stop there. You don't have to write lots of them. 1000n will be 3657.5757. Oh, this time it's matching. So I can see this one and use this one and that one. So next step, I'm going to write 1000n equal 3657.5757. Subtract 10n equal 36.5757. Da-da-da-da. Subtract them, and then you get 1, 2, 6, 3. Those gone. 1000 take away 10n is 990n. Okay. Next, so you need to do n equals to 3621 divided by 990. 3621 is not an even number, so 2 doesn't go into it. 3 looks like it does go into it. Now, apart from you can add the digits, this one is quite obvious because, 36, if you split the whole number into 36, 21, both of these are divisible by 3, so the whole thing is divisible by 3. So I can divide top and bottom by 3 to simplify it, and that will give me, if I divide by 3, 36 divided by 3 is 12, 21 divided by 3 is 7. Now, not 127, is 1207 over 330. I need to check if it's divisible by 3. 1 plus 2 is 3. 3 plus 7 is 10. So it's not divisible by 3. Not divisible by 5. What about 11 though? Not as well. So yeah, we're done. Here comes practice question 2. Okay, have a go at the question. Pause the video. When you're ready for the answer, you can press play. So here are the answers. Okay, A, B, C, they are not too tricky. Use n, 10n, 100n. You like the recurring decimals on the first one right after decimal point. These are the most straightforward ones. So ABC, 1 digit 10n, 2 digits 100n, 3 digits 1000n. D, however, the recurring decimal doesn't start after decimal point, so if you do a little bit of trick, you do 10n, 100n, use them too, and simplify, divide by 3. Again, 1 plus 4 plus 7 is 12. 12 is divisible by 3, so you know the whole thing is divisible by 3. E, for last one, you have to do a bit more work, 100n and 10,000n, and then when you subtract them, you get 4,988 and 9,900. A quick shortcut for you to determine if a number is divisible by 4. So I'm going to leave you with that one before I let you go. So the skill is, if the number is the last 2 digits of a number is divisible by 4, then the whole number is divisible by 4. For example, 4,988, because the last 2 digits 88, 88 is divisible by 4, so the whole number is divisible by 4.
Did you know that? I did not know that. Well,
Now you know.
9,900 is divisible by 4 again, because 00, last 2 digits, is divisible by 4. Well, how? Well, 4 times 0 is 0. Therefore, 0 is divisible by 4. So think of this one. What about this strange number? Is this number, the whole number, divisible by 4? Well, it is, because 48 is divisible by 4. So if you want to do the bus stop method, you divisible by 4, you will find a whole number as the divisor.